Hello. So today we'll have a look at the problem called valid parenthesis. We will be given an integer n, and let's take n equal to 3. And what we have to do is we have to return all the valid combinations of n pairs of strings. So if we have n equal to 3, we call this generate parenthesis. So actually this code is recursive solution from the book Cracking the Coding Interview. It's not the efficient solution, but it is a solution, and we will have a look at this solution. Let's take a stack. And when we call the function with n equal to 3, and when n equals to 3, we see that this base case of our recursion is n equal to 0. So n equal to 3 is not true. So we go to this part and we call the function recursively with n minus 1 parameter. So we say first we call to 3, and then we call to 2 and 1 and then 0. And when n equals to 0, we return a set with an empty string. So when n equals to 0, our set contains one string, which is an empty string. So we go one level down, and so this part from 0 has returned a value, so we go to the loop parts. For outer loop, we go through each string in a set, and for each string we check each character of a string. For when n equals to 1, we have a set which contains only an empty string, so there is no character in it, so we just insert a new string to our set. So in this part of our code, we are inserting valid combination plus a string. So it will be, and currently our string is an empty string, so it doesn't change anything in the string. So we just have in our set one string, which is one valid combination of parentheses. And since we had only one string in our set, the loop is done, so we just return this set. So the second level of the recursion is done, so we are in a part where n equal to 2, so we return from this part where n equal to 1 to the level up, let's say, in the recursion tree, and we are returning to the previous this set, which consists of one string. So if our previous currently consists of one string, so we check each character of our string, and if the character of the string is an opening parenthesis, and it is, in our case, the first character is an opening parenthesis, we call insert inside function. So this insert inside function takes a string and left index. So what does it mean? So our string is this. So we've got this opening parenthesis, and anything before opening parenthesis goes to the first part, to this left part, and anything after our opening parenthesis goes to the second part. And we insert in between the first and the second part of the string valid combination here, and we return that string. And it also is inserted to our set. So this is first, and the second character of our string is the closing parenthesis. So this condition is not true, so we don't do anything, and we are out of this inner loop, and we insert to the set a valid combination plus a string. Currently our string is itself a valid combination, so the second string will be as follows. So we take this string of valid combination of pair of strings plus the string itself, and it is inserted to the set. So our result set from where n equal to 2 is this, and we return from the level where n equal to 1, and we are back in a level where n equal to 3. So when n equals to 3, our previous, so this generate parents to return a set to the previous set, and it consists of these two strings, and we check each character of each of the strings. The first character consists of two opening parentheses, so for each opening parenthesis we call this insert inside function, where we split the string into two parts. The first part is anything before the opening parenthesis, and the second part is anything after this opening parenthesis. So we insert one valid combination, and the second part, and this goes to the set. This string is inserted to our set, and the second character is also an opening parenthesis. So we take the first part, we call this insert inside, and we split this string to two parts, and we insert one valid combination in between the first and second parts, and this is inserted to the set. And we are done with our first string in our previous set, and we consider the second string. In the second string, the first character is an open parenthesis, so we split this string into two parts, and we insert a new combination in between the first and second parts. This string also goes to the set, and then so it is 2.1 actually, and 2.2, and in the second character is a closing parenthesis, so we ignore it, and then we see that the third character of our string is an opening parenthesis, so we split this again into two parts and insert a valid combination between these two parts, and this valid string goes to our set as well. And the last character is an opening parenthesis, so we don't do anything, and we are done with our inner loop. So actually, backing up, we see that when we first considered the first string, we created these two strings, right? As when we're done with these two strings, we are done with the loop, and we go here and we actually create one more string where we say this combination plus our current string, which is, so we get a new string which is inserted to our set. And only after this string was created, we went to process the second string. After this second string has been processed, the third string is created again, since this inner loop is done. So we create this same string again, and we put it into our set. But since the set is a data structure which has only unique elements, at the end we will have only unique elements of our combination. So our end result, so we are done with the tree, and our end result will consist of, since these two are the same strings, we can say that we put only this string into our set, so we have these 5 strings in our set. So this generate parents with a parameter n equal to 3 returns 5 elements.